Okay, today we're going to look at systems of linear inequalities. And just like systems of linear equations, a system of linear inequalities is two or more linear inequalities that are graphed together on the same coordinate plane. The solution's a little bit different. So the solution to a system of linear inequalities is the region that makes each inequality in the system true. So in a system of linear equations, we had three possible solutions. They intersected. That gave us just one solution. There was only one point that worked in both equations. Or they did not intersect. They were parallel. Or they were the same line. So most of the time we were looking for a point of intersection. With a system of linear inequalities, we're going to have many points of intersection. And that double shaded area, we'll see that in just a second, is the solution set to our system of inequalities. So we're going to graph y is greater than 2x minus 5 first. And our y-intercept is negative 5. It's up 2 and over 1. It's a dashed line because it's y is greater than. There's no equal to sign. And we are going to shade above the line because it's greater than. So everything in this red shaded area is a solution to the inequality y is greater than 2x minus 5. We're going to graph the second equation. 3x plus 4y is less than 12 on the same coordinate grid. But first, I want to change this into slope-intercept form. Y is less than negative 3/4 x plus 3. My y-intercept is at 3, down 3, and over 4. Or I can go up 3 and to the right 4, or to the left 4. And again, this one also has a dashed boundary line because it is less than and not less than or equal to. So we're going to shade below the boundary line. And if you'll notice, I have this area right here is double shaded with blue and pink, and then there is a section that's just shaded with blue. So our solution to this inequality is this double shaded area right here. That, on this graph, is the solution to our systems of inequalities. So any point inside that double shaded area will work in both equations. It'll work in y is greater than 2x minus 5. It'll also work in 3x plus 4y is less than 12. And we can pick my favorite point, 0, 0, and 0, 0 will work in both equations. Okay, so we're going to work backwards again. We're going to look at this system of linear equations. This gray shaded area in here, this gray part in here, is the solution to this systems of inequalities. What is the system? So we're going to look at this line first, this boundary line right here. The boundary line is solid and everything is shaded below the boundary line, so we know that it's going to be y is less than or equal to. So for this boundary line, our y-intercept is positive 7, and our slope, I'm going to use this 0.48 up here, is a positive slope, has a rise of 1 and a run of 4, because my x-axis has intervals of 4. So a rise of 1 and a run of 4. So the inequality for the red boundary line is y is less than or equal to 1/4 x plus 7. The other boundary line, the blue one right here, this blue boundary line right here, again is a solid boundary line. So we know it's going to be y is either less than or equal to or greater than or equal to, and everything here is shaded above the line. So y is greater than or equal to. My y-intercept is down here at negative 5. And I'm going to use the point 0, negative 2 to find the slope. So my rise is 5, and my run is 2. It's a negative slope because it's going downhill, so my slope is negative 5/2 x minus 5. Okay, graph number 2. So we'll look at this solid boundary line right here. It's solid and everything is shaded above, and the whole thing is not shaded. If we were to shade this whole boundary line, it would be that section right here. But this graph is just showing the intersection of the shaded areas of the two inequalities. So we know that this one is going to be y is greater than or equal to whatever the equation is. My y-intercept is at -1, and my slope, I'm going to use this point 2, -3 over here. My slope, my rise is 2, and my run is 2. It's a negative slope, so -2 over -2 is just -1x minus 1. And we could also write that as y is greater than or equal to -x minus 1. My second boundary line is this dashed boundary line right here. So dashed tells me that I'm not going to have equal to in there. So it's y is greater than, because everything is shaded above the boundary line. So y is greater than, my y-intercept is here at 2, and I'm going to use, let's see, find another point. We'll use this point right here. So my rise is 1, 2, 3, 4, and my run is 1. So my slope is 4 over 1x plus 2. So y is greater than 4x plus 2. And the gray shaded area is the intersection of these two inequalities, this system of inequalities. Y is greater than 4x plus 2, and y is greater than or equal to -x plus 1. And you know what? I made a mistake. It's a -4x because it's going downhill. So it's a -4x plus 2. Now we're going to take a look at a real-world example using systems of linear inequalities. A zookeeper wants to fence a rectangular habitat for his goats. The length of the habitat should be at least 80 feet, and the distance around it should be no more than 310 feet. What are 3 possible dimensions of the habitat? So we're going to define our variables. We're going to let x equal the width of the habitat and y equal the length. And what we know about the length right here is the length of the habitat should be at least 80 feet. So y should be greater than or equal to 80. There's our first inequality. So we know from geometry that the perimeter of a rectangle is 2 times the length plus 2 times the width. So that's our second inequality. 2 times the length, which is 2 in our case y, because we had the length equal y, plus 2 times the width, which is x, can be no more than 310 feet. So less than or equal to 310. I'm going to leave this one in standard form. 2x plus 2y is less than or equal to 310. And so when I graph that, I'll graph that using the x and y intercepts. So as you can see, I've labeled my x and y axes. My x-axis is width, and my intervals are by 20, and my y-axis is length, and my intervals there are also at 20. So the first inequality I want to graph on here is y is greater than or equal to 80. So that's just going to be a horizontal line at y equals 80. It is a solid boundary line because it's greater than or equal to, and then I'm going to shade everything above that boundary line. That's everything up here. It's going to be shaded in blue. The second inequality I'm going to graph is the perimeter inequality. I'm going to graph using the x and y intercepts. So for my y-intercept, when x is 0, my y-intercept is 155. for my x-intercept, when y is 0, my x-intercept is also 155. So I'm going to graph that inequality using the x and y intercepts. So my x-intercept is at 155, which is about right about there-ish. And then my y-intercept is also at 155, which is right about there. And I'm also going to have a solid boundary line on this one because it is less than or equal to. So my solution to this inequality is anything, well, sorry, now I need to shade it. It is less than or equal to. So less than or equal to is everything underneath and including the boundary line. So my double shaded area is this area right in here. So all of those ordered pairs in there will work for my inequality. So we're going to pick a couple of ordered pairs that work in there. We have to make sure that our length is greater than or equal to 80, and whatever width we choose keeps the perimeter of our rectangle under 310. So I'm going to pick the point 20, 100, which is right here. I'm going to pick the point 40, 100, which will also work, and I can pick the point 10 and 120, and that will also work. So here are the 3 points that I picked for my 3 possible solutions, and I'm going to check them. So I'm going to make up a little table right here. And for my table, I'm going to have my width, my length, and then my perimeter. So one point that I picked was 20 and 100, and so my perimeter has to be less than or equal to 310, and my length has to be greater than or equal to 80, which this one is. And if my length is 100 and my width is 120, my perimeter is going to be 240. And is that less than 310? It is. The other point that I picked was 10 for my width and 120 for my length. If I do that, I get a perimeter of 260. And then the third point that I picked was 40 and 100. So if I do that, I get a perimeter of 280. And as long as all of these perimeters are less than 310 and all of these lengths are greater than or equal to 80, they will work in my system of equations, or linear inequalities. Once again, it is your turn to answer these questions on the Google form. There are at most 12 bicycles and tricycles in the school playground. There are at least 14 wheels altogether. So how many wheels are on a bicycle and how many wheels are on a tricycle? Use that information to write a system of linear inequalities to describe this situation. Number 2, which of the following point is a solution to the following system of y is greater than x and y is less than 3x minus 4? List all that apply. So when you're listing your answers, you can list them as we'll just list them as 1, 2, or 3. And it might be all of them, it might be one of them, and it might be none of them. But be sure to put them in the Google form provided in Google Classroom.